All right. So let's go over some of these questions. Now, the ones that we did yesterday, they are relatively easy. Okay. So let's just go over. Let's start with the first one. Now, for these questions, we have the differential operator. Okay. So let's start 2a d of x of 2x minus 3 times x plus 4. Okay. Now, this one, what you have to do is you have to remove those circular brackets first. So you use FOIL before you find the derivative. Now, since we are not differentiating straight away, we have to continue writing d of x until at that point when we decide to differentiate. So this will be what d of x of 2x squared plus 8x minus 3x minus 12. Then I have to simplify that, so that becomes d of x of 2x squared plus 5x minus 12. Now this function, okay, it's quadratic. So now I'm going to find the derivative of each term, okay? So this becomes the exponent times the constant, we get 4x to the power of 2 minus 1 plus 1 times 5 x to the power of 1 minus 1, the derivative of a constant, 0. So the final answer here is going to be 4x, right? 1 minus 1 gives us a 0, x to the power of 0 is a 1. 1 times 5 gives us a positive 5. So, all right, so that's the first one. Now I want you to just make sure that you are very careful of the notation. Look here, I'm writing d of x, and the d of x is on the right hand side. It's not on the left hand side of the equal sign. Yeah. And you don't write d of x equal to, no. If I see you writing that, then I'm going to ask you who taught you that. Okay. So that's the first one. Then I'm going to do the ones with square roots as well. Because in your control test, you're going to see a question with square roots and with fractions. Okay. So let me do C. Okay. Or maybe I can start with B. Right. B is very straightforward. That's d of x of 2 over 3x to the power of 4. Now, as you can see, that x to the power of 4 is part of the denominator. So we need to take it to the top, that it becomes part of the numerator, which means its exponent changes from being positive to negative, so it becomes 2x to the power of minus 4 over 3. Okay? It becomes 2x to the power of minus 4, and I told you yesterday why it becomes x to the power of negative 4. That comes from this law, x to the power of minus n equal to 1 over x to the n. So we are moving from the right hand side towards the left hand side. Okay? Then here, you can write this as g of x of 2 over 3x to the power of minus 4. The same thing. Then you multiply the exponent, which is negative 4, by the constant. So if you do that, I'm finding the derivative now, so it becomes minus 4 times 2 over 3x to the power of minus 4 minus 1. Right? Then here, I just have to multiply the negative 4 by 2, I'll get negative 8. So my final answer will be minus 8 over 3x to the power of negative 5. Okay. If you want, you can convert that negative exponent to a positive one by taking that x to the back to the denominator, and its exponent becomes a positive exponent. Okay, but we can leave it like that. All right? Then let's move on to the one with the square. Okay, that's C. The one with the square. Okay, C. But if you want to score marks in your June control test, can I have your attention? You know what? If the teacher starts giving you some hints when you are getting, you must take it serious. Do you understand? And make sure you know what we are doing now, because you are going to see it very soon. All right. So part C, the question is d of x of the cube root of x, d of x of the cube root of x, okay, plus 1 over square root of x. Right. Before you find the derivative, if you see a question like this, you have to remove the square root. That's number one. Number two, you have to remove that division line. Okay, so this will become d of x. I'm not finding the derivative as yet. I'm simplifying to a form that can be differentiated. So this is the same as x to the power of 1 over 3 plus this one here. First, I'm going to simplify it as 1 over x to the power of a half. Okay? Then, since the x is part of a denominator, I need to take it to the top, but the exponent of x becomes negative. Can you pay attention? Can you pay attention, please? Pay attention. G of x to the power of a third plus x to the power of minus a half. I'm not finding the derivative as yet. I'm simplifying so that I can be able to get the expression to a form that can be differentiated. Now we can differentiate. There are no brackets, there are no square roots, the x is no longer part of a denominator. Yes? Go. Okay. I hope you are aware that if I give you square root of x like that, if you want to write it in exponential form, we have a hidden 2 here. What is square root? So this becomes x to the power of 1 over the hidden number here. It's a what? The 2. Right, I expect you to know that. Yeah. Right. Okay. So from here, then now I can find the derivative. Now we are dealing with the rational exponents. This is what you are going to see in the June control test. So I'm going to make sure that I explain it as much as I can, and then when you see it, you won't say, I've never seen this before. So what happens next is you stop writing d of x. You stop now. The expression is simplified, no brackets, no square roots, no division lines. Okay? So the constant term for the first term is a 1, so it becomes 1 over 3 times x to the power of a third minus 1. I encourage you to write it this way so that you don't make silly mistakes. Right? Then here, this plus, it means that the number which is in front of that x there, it's a positive 1, times this minus a half, you get minus a half x to the power of minus a half minus 1. Remember, when you are differentiating, you have to subtract 1 from the original exponent, always. No need to get confused. So the final answer, we can write it as 1 over 3x to the power of negative 2 over 3. Don't try to do it mentally like me. No, sir. A third minus 1, you can put it in your calculator. Okay? Don't say Mr. Disfonda does it without a calculator, it's shy. Minus a half x. Now this is minus a half minus 1. That's minus 3 over 2. So why should you try? Right. So you stop there. Well, I want you to be aware that you can also convert these negative exponents to positive, but I don't want you to go there. Just stop there to avoid unnecessary complications.
So it's right like this.
Yeah.
So I mean, just show me how to remove this. So
All right. First, you have to know this. The nth root of x raised to the power of m is the same as x to the power of m over n. You have to know that first. Okay, and I told you about it yesterday. Right? So this 1 over 3x here, we can write it further as x to the power of negative 2 over 3 over 3 minus x to the power of minus 3 over 2 over 2. This is the same way. Whereby you multiply this 1 by x, you get x. This 1 by x, you get x. That's why we end up having the term x as part of the numerator. Then we apply this law. Let me use a different color. X to the power of minus n equals 1 over x to the n. Okay? But we are moving from the left hand side towards the right hand side. So we are moving in that direction. Which means this is going to become 1 divided by 3 times the cube root of x squared. This will be very complex. And 1 over 2 times the square root of x cubed. Okay. If you can understand it, that will be fine. If you don't, that's why I said stop here to avoid issues. Okay. We'll try our paper, we'll just make sure we give you marks up to date. Okay. It's most likely that you write it external.
external.
Yeah, for the trial. Okay. Any questions? All right. Hey, can you pay attention, please? I need to get on it. Right, let's do D. Okay. Now, as you can see, all these questions they require knowledge of exponents. If you have got challenges with exponents, you are going to find that finding the derivative will be a challenge. So that's 2x times x to the power of minus 3 over 7 minus 3. Okay, let's do that one. So it's d, that's d of x of 2x times x to the power of minus 3 over 7 minus 3 plus 6ax. Right? So first things, before you do anything, remove the bracket, the circular bracket. So it will be d of x of, if I multiply here, I need to be aware that the exponent of this x is a what? It's a 1. Can you pay attention? So 1 plus minus 3 over 7. I'm using the first law of exponents. If you are multiplying bases that are the same, you add the what? The exponent. So this 1 here will be added 3 over 7. So that would be like 3. That would be like 7 over 7 minus 3 over 7. So you get 2x to the power of 4 over 7. If you are looking outside there, you will miss it. Minus 6x plus 6ax. Laws of exponents. First law of exponents, second law of exponents, you need those when you are dealing with finding the derivative. Exponents are one of the key topics that you require for you to be able to find the derivative of a function. Now that we don't have brackets, we don't have division lines, and we don't have what? What else? Square roots. Three things that you must not have for you to find the derivative. So now I can find the derivative now. So exponent times the constant, so that will be 4 over 7 times 2x to the power of 4 over 7 minus 1. Right? Then the derivative of that will be the exponent times 6, you get 6x to the power of 1 minus 1, because the exponent here is a 1. Also the exponent there is a 1. If the exponent is not written for a variable, it means it's equal to 1. Then 1 times 6, that gives me a 6a times x to the power of 1 minus 1. Then let's simplify. 4 times 2, that's 8, so we get 8 over 7 x to the power of, now that one will give me minus 3 over 7. Okay? Then minus 1 minus 1 gives me 0, x to the power of 0, that's 1. 1 times minus 6 gives me minus 6. Again, here, 1 minus 1 is a 0, x to the power of 0 is a 1. 1 times 6a will give me positive 6a. So this will be the answer. If you want, you can simplify to make the exponent mean positive, but I would suggest that you stop there to avoid unnecessary issues. Okay. Any question?